Next question, how can we find the displacement when the initial velocity, over here, is not zero? We've shown how the displacement is the area between the graph of v, the curve that shows the velocity, and the horizontal axis, time, during the given time interval. But what if the area is not a simple rectangle or triangle? Well, we have some steps here. First, break the region into rectangles and/or triangles. Then find the areas of the individual shapes, where the rectangle is height times base, and the triangle is half times height base. Then add them all up, and that will be your displacement. This graph shows the velocity versus time for a girl starting a run. How far does she travel in the first 10 seconds? First thing, make sure you mark off the time that we're interested in. In this case, it's 10 seconds, so it's using the full graph. But if they had said in the first 4 seconds, you would have terminated it right here. So let's break it into a rectangle and a triangle. Here's our initial velocity. This piece gives us our rectangle. Okay. Then what do we have? We have an acceleration or an increasing velocity, and that's our triangle. So we're done with the first step. Let's work with the triangle first. We have a base of 10 seconds and a height of 4 meters per second. Well, where did that come from? Well, we went from 2 to 6. 6 minus 2 is 4. So the area of the triangle is 1/2 times 4 meters per second times 10 seconds. And what do we get? We get 20 meters. Now let's do the rectangle. We have a height here of 2 minus 0, so that's just 2 meters per second. We have the 10 seconds again for our base, and that gives us 20 meters. Finally, step 3, add up the two areas, 20 plus 20, we get 40 meters. That's the displacement.